Hi, welcome to class. My name is Don Lafond, Professor Don, and this week, as a bonus, I am recording CCNAv6, Chapter 2, Static Routing, as a refresher for my Cisco 2 class. Cisco 2 doesn't really go in depth with static routing, so I'm going to go ahead and record this for that class. If you're watching this as a recording, ask your questions in our help discussion forum. If you're watching it live, you can ask me at the end of the presentation. And if you're asking it, if you have a question and you're watching this on YouTube, ask your questions in the comments below and I'll do my best to answer them. Let me go ahead and start the presentation. I'll share my screen first. This presentation will take about half an hour or so, give or take 5 minutes. Nope, starting from the wrong place. It's okay, starting here. All right, CCNAv6, Chapter 2, Static Routing. Talk first about static and default route concepts. So a router learns about remote networks in two ways. You can manually enter into the routing table using static routes, and static routes are not but you got to realize static routes are not automatically updated and must be reconfigured when the topology changes. Or routers can learn about remote networks using dynamic router. Dynamic routes are learned using a routing protocol such as RIP, OSPF, and EIGRP. So let me zoom in on this. So here we have router 1 that knows about the 10 network and the 11 network. And we have our router 2, and it knows about the 10.1.1 network and the 10.1.2 network. Now, in this case, we could manually configure our paths to the other networks, or we can set up router 1 or router 2 under using RIP, EIGRP, or OSPF. Now, because router 2 is going to take all of router 1's traffic regardless of where it's going ultimately, whether it's going to these two networks or out to the internet, we can set up one default static route that will send all traffic to R2. If router, on the other hand, router 2, that's over here, I believe. No, that's dynamic routing. Okay, router 2 knows about its two networks, but it has to have two routes. You'd have to set up two separate routes. One route going this way to talk to either the 10 or the 11 network, and one route going this way to talk to the internet. All right. Now, that is static and default routing. The other one is dynamic routing, and R1 and R2 just chatter saying, hey, I'm using EIGRP and I know about these networks, and they just chatter back and forth telling them each other everything it knows, and then each router adds to its routing table. Now, why would you use dynamic, or when would you use dynamic or static routes? Well, you would want to use, when you're using dynamic routes, they're generally independent of the network size. So dynamic routes you could apply on a very small network with two routers, but it's a lot of extra work when you can just set up a default static route. Now, as you wouldn't want to use it, a static route is great in a small network, but it doesn't really work with a big network, because anytime there are any changes, you would have to go in and reset up all of the static routes. And that's what it says under topology changes. Dynamic routes automatically change, but the administrator has to actually apply changes to static routes. Scaling, it's great for dynamic or complex And static routes, you can only really use it on simple topologies. Security. Now, dynamic has a weakness in the fact that it's always chattering, right? So if somebody hooks up or gets into your network with another piece of gear, they can hear all of that conversation. They might be able to steal data or do bad things. But static routes, there's none of that chattering because you set up the addresses, so they're not communicating. Also, with dynamic routes, they use more CPU, memory, and link bandwidth with all that chattering, and actually having to process the routes. If something changes, it reroutes automatically. Whereas static, there's no extra resources needed because the route is static. It doesn't change, so the route is already set. There's no CPU processing required. And predictability. The route depends on the current topology and dynamic. As the topology changes, so do the routes. With static routing, the route to the destination is always the same. When to use static routes? With smaller networks that are not expected to grow, routing to and from stub networks. A stub network is accessed by a single route and only has one neighbor. So this is a stub network for router 1. Actually, I guess it's for router 2. This whole thing, if there's nothing else connected to router 1, then this whole thing conceivably is a stub network. A single default route to represent a path to any network not found in the routing table. Use default route on R1 to point to R2 for all other networks. Use static routes to connect to a specific network, and I'll show you that later. You can summarize routing table entries, which reduces the size of the routing advertisements, and you can create a backup route in case a primary route link fails. We call that a floating route, and I'll show you how to do that. A standard route. To configure R2, R2 is configured with a static route to reach the stub network 172.16.3.0. So in R2, you are setting up a you can simply use a static route to get here, and I'll show you that command in just a minute. Default static route is used when a packet does not match a specific route in the routing table. Default static routes use quad 0, it's 0.0.0.0, and then 0.0.0.0 as the destination IP4 address. It creates a gateway of last resort. Commonly used. The common use is when connecting a company's edge router to the ISP network. Router has only one router to which it is connected. So here's the stub network. Let me zoom in a little bit so you can see that. And all I need to know about for anything that's not on this network is to send it through the default static route quad 0s at the bottom. It shows up at the bottom of the routing table and indicating that everything goes to R2. Now, a summary static route, multiple static routes can be summarized into a single network address. Destination networks must be contiguous. And there are some rules if you're going to set up a summary route. Destination networks must be contiguous. Multiple static routes must use the same exit interface or next hop. In this figure, 4 networks are summarized into one summary network. So we have one. Here we go. Let me get my laser whip. So we have 1 network, 2 networks, 3 networks, and 4 networks. It's the 0. Let's see, 21, 0, 22, 20, 21, 22, and 23 networks. These 4 networks, instead of having 4 entries in the routing table, they will just have one single summary route. And they don't actually require you to set up summary static routes in Cisco 2 in this class. So I'm not going to explain the process, but there are plenty of YouTube videos that you can go to that will walk you through step by step to be able to figure out how to create this address from these 4 networks. And it's not difficult. I'm just not going to do it with you right now. Floating static route. Static routes that are used to provide a backup path. It's used when the primary route is not available. It's configured with a higher administrative distance. And remember, administrative distance is the trustworthiness of the actual connection than the primary route. An example, EIGRP administrative distance is equal to 90, so you can set up a backup floating route with the administrative distance of 90, 91, 95, whatever, or higher would serve as a backup route and will be used if the EIGRP route goes down. So here we have a primary private WAN address, and this is the primary route. And then, just in case this ever breaks, you want it to kick into the backup route, the floating route, and I'll show you how to configure that in just a little bit. So the IP route command, IP route is for IPv6, I'm sorry, IPv4, and IPv6 route is for IPv6. So the command is pretty simple. It's IP route to create a static IP route, and then what network you're going to, what the network address is, and then what the subnet is for that address. And then either the next hop IP address or the exit interface. And that's what that says down there. You can also set the administrative distance, which is just another number that goes at the very end, 91 for our example. Now, in this example, we're going to do a next hop static route. In this example, only the next hop IP address is specified. So remember, if you're creating a static route going this way, you're not using your IP address, you're using the next hop IP address. Now, let me zoom in so you can see it. So here, to get to the 16.1 network, to get to the 168.1 network, and to get to the 168.2 network, they're all the same next hop IP, this guy right here. Now notice you don't have 172.16.2.0 listed here because that's a directly connected route and that'll be determined automatically. We're talking about other routes that we're teaching the router on how to get to. So the router knows now that it needs to go to the next hop IP address here. But it has to do a recursive lookup. A recursive lookup means that R1 has to look at the routing table to figure out where this IP address, here's the next stop IP, 172.16.2.2. That's 116.2.2. That's this address. Notice it's the same address. So it has to look up in its routing table to figure out what exit interface to send to that address. And then here it explains that to get to that address, it has to look through the routing table to find the 172.16.2.2, and now it knows where to send that address. But it has to take the processing to do that. So the next thing it's showing you here is to use the exit the next thing is it's saying you can also use the exit interface. That's what I thought it did. It just didn't say it at the top. So here you see the same networks that we're connecting to, here that we did just a moment ago with the next hop IP address. But now we are using an exit interface. An exit interface may be preferable because it requires less processing. And you can see once it's added, you can see that it has a static route, and after we add those static routes, you can see that it shows the network, and it's directly connected through serials 0.0.0. Okay. And now I just gave you two, so you can create a static route by using the next hop IP. You can use the exit interface, and guess what? You can use both. So you can create a fully specified static route where both the exit interface and the next hop IP address are specified. When the exit interface is an Ethernet network, fully specified static routes are used. Note, with CEF, which is a, a, a switch forwarding mechanism, a next hop address could be used instead. So let's take a look. So here you see that you have an IP route to a network with a subnet, and then notice you have the exit interface. Notice you have the exit interface and you have the next hop IP address. Now there is no need for the extra CPU processing because you're giving everything you need to the router to be able to make that connection. And then here we have what that looks like in the IP routing, in the IPv4 routing table. And you can see you have via this next hop IP and this exit interface. Verifying a static route, you can do so in several different ways. You can run a show IP route that opens up the routing table. You can do a show IP route with an address, the actual address you're looking for, and it gives you some specific information, including traffic. And then you can do show running configuration and then do a pipe and jump to section IP route, and you can see your configuration there. Now the default static route, remember my example of the stub network where everything is going to router 2. Default static route is commonly used when connecting an edge router to a service provider network and to a stub router, a router with only one upstream neighbor. Default route is used when no other routes in the table match. So the command is IP route and quad zeros. You just type all zeros there. It means everything. This means it matches everything. So if it doesn't match in the routing table as it moves through, the default static route is at the very bottom, and it says, all right, well, if you didn't match anything above, then you're going to go this way, and it sends it on to router 2. And again, you have to have the quad zeros, and then you put IP addresses as next hop or exit interface. Here we have configured it. And on R1, IP route, and you can do next hop. Here they show it in the network, and they also show you the asterisks. For IPv4, the asterisk indicates that it's a candidate to be the default static route, the gateway. So that's what the asterisk is. Now IPv6 doesn't have that asterisk, so I'll just tell you now. But IPv6, you put the command is IPv6 route. Then you put the prefix length, and then the next hop IP address or the exit interface. Remember, you always have, first thing, whenever you're dealing with anything with IPv6, first thing you do is turn on unicast routing. Otherwise, none of your commands are going to do anything. You can do next hop. Here, we are configuring it using, here it is right here. But I don't think that tells me. Oh, we're just showing the IP route. Okay, we're using the show command. They're not actually configuring it here, but you can see that you have uh, connected, directly connected, and local link, and then I'm sorry. What this is saying, um, it's able. We have a problem. This isn't actually showing the configuration. This is showing that because you don't have these networks, the 3 network and the 4 network, oh wait, what's that up there? The 2 network and 3 network, because you don't have those 2 connected, it's not in the routing table and those packets are all going to get dropped. The 4 network is connected because it's directly connected. So when you ping, this port or that anything on this router, you're not going to be able to get a return. That's all that's showing. I don't know why it's not showing the configuration. Maybe that's coming in a minute. Oh, it is. I'm sorry. Okay, so hang on a second. I went ahead and took a moment and fixed the slide because I want to be able to see problems the next time I run across this instead of wasting your time trying to figure out why the configuration isn't working here. Isn't here, I should say. All right, so let's continue. And now we're going to actually configure IPv6 static routes. And just like in IPv4, you can have next hop static IPv routes, you can have directly connected static routes, and you can have fully specified static routes. So here they start us off with the next hop IP, this for networks, port 2. And then that's the same. Notice it's the same for all 3 networks. This one, that one, and this one here. And then they have showing inside of after we've added those addresses, you can see that they're static routes. They've been added and they have the IP via the next hop IP address. You can also do it with the exit interface. Here, S000, that's this port right here. And you can see in our you can see serial 000 to get to the 2 network, the 3 network, and the 5 network. And then you can also do fully specified. Now, before they show you fully specified, they explain that you can't create a next hop IP address using the link local address of FE80::2. And that's because, as you guys know, many different networks can have the same link local addresses. Link local is for communication within the IPv6 network itself. So you can't set R1 and have a next hop for R2 as FE80 because R1 could also be connected to R3 and it could have an FE80. And which FE80 do you use? So if you ever try to create an IPv6 route, a static route using the next hop private address, link local address, I shouldn't say private, link local address, then you're going to get an error message, and that error message will say interface has to be specified for a link local next hop. It should say fully specified, or it should say, it does say the interface, it should say also specified. So anyway, so here they did it again with here they did it again with the just instead of using the link local next hop, they used the exit interface of S001 here. And then they did a show and they just showed that connection. So you can get to the 2 network via the next hop IP address, and notice it's fully specified with the exit interface. here to verify, you can do a show. You can do a show IP route, and in this case, they've narrowed it down to static, so it eliminated all the directly connected and the link local. I mean the link, the C's and the L's. It got rid of all of those, and they're still there. We're just seeing just the static addresses. You can see that. And we can do a show IPv6, same thing. And you can see the one address that was created. And here they did IPv6 route, and then they added a route so that you can find out information about that. And then here with show running configuration, and then they jump down to a section for IPv6 to show the network's connections for that. And then just like we could create a default gateway for the IPv4 network, we can create a default static IPv6 route for all addresses that do not meet an earlier address in the IPv6 routing table. And it's just : 0. And again, this is the same thing. Remember, you get rid of all the zeros in an IPv6. So this is really all zeros and then all zeros. Same thing in IPv4, nothing special there. Except instead of typing out quad 0, who would want to type out 128 zeros, right? So you do : /0, and that is the parameter. And then you can use the next hop, the exit interface, or both. And here they show you using the next hop. So send all IPv6 traffic that does not meet anything above, send it to : this says send everything to the next hop IP address here. Or you can do the exit interface or both. And then they want you to see here that the S does not have an asterisk in IPv6. This is the default gateway. It will always be the last entry in your routing table. And here they just throw in floating static routes because we're going to learn about floating static routes in a minute. Here are a whole bunch of different administrative distances, but we really care about EIGRP, IGRP, OSPF, RIP. These are the ones we use currently. Remember, static is 1, and of course, directly connected is 0. So all you need to do is, if you're running a dynamic EIGRP between routers, all you need to do is set up all you have to do, if you're running EIGRP, you can set up a static default route with with any number higher than that 90. And the reason why you can do that is because, let's say your EIGRP goes down for one reason or another, I don't know, it will kick into the static. More so if your static route goes down, it'll float, if you will, to the other route. So 5 is what we use here. When this line goes down, when this connection goes down, we use this connection. So primary, and then when that goes down, or if it goes down, then we go to backup. And all we do to make that happen is we just add a number. So here in our network, the preferred route is to R2 this way, but you can see it's the preferred route. But we also we enter the floating route, and the 5 here says that it's going to be the backup. And the backup is going this way. We're going to use 10.10.2, this network and that connection right there. Now I want to say that you won't see the backup route in your table, because remember, only the best route is shown in the routing table. Now, to prove that, you can break the link. Do they show that here? To prove that, yeah, they test it. They break the link. Actually, they break it by they prove it first. So they prove that it works. and they do a trace route 192.168.2.1. That is here, and it works. And it returns a signal, which a trace route, and it went via 172.16. You can see that it went via 172.16. So it went this way to get to that network, and it did it quickly. And then they also then shut down interface S000. So they shut down this interface on R2. Notice you're in R2 now. So in R2, they shut down this network, and then they redo notice the change state to down, and then they go back to it again. I don't see where they did the test here, but they turn it back on. No, they shut down another interface. Why'd they turn down another interface? Probably just to stop error messages. But what? R2 interface S001. They shut down this one too for some weird reason. I think shutting down this is enough. You don't need to also shut down that one. They just do that to confuse us teachers. And then they ran it, and you can see that they did an IP route, and you can see the static via by 10.10.10, and then they did the trace route, and you can see that it went by 10.10.2. It went by here to get to that network. So proof that it works. And you can configure an IPv6 static route in the exact same way with the exact simple number of 5, even though it's a fancy IPv6 address. And then remember, it will only show the primary route, right? It won't show the backup until you bring it down and then test it, and then it works and all that. Now, the final thing that I believe they talk about is configuring a static host route. Now, here we're talking about creating a network connection from a branch to a specific, through the ISP to a specific router. So the IPv, so we want one address here. So let's see, and so here we have, we're going to 209.165.200.238 right here. We're going here, and we are getting there via 198.51.100. That's here, .2. This must be the .2. It's not listed, but this is the .1. From branch, if you wanted to talk to the server, you can go directly there without going to a network. You can just go to an absolute address. And remember, the 32 indicates an absolute address inside of a IPv6 network. This says we're going to one address, the one network, and it's directly connected to S000. So this is the one, and it's directly connected to 000. And then we got the other side already set up. Now you can do a show, so you can see that inside of our IPv6 routing table. Actually, this they combined. No, it's still IPv6. So here we have, they said no IPv6 route, so they stopped the old route, and they made a new route just to a specific address using a fully specified address. Here they did it with just the next hop IP, and here they did it with fully specified, and they probably wanted to show you they had to use fully specified because it's going to a link local, although they don't show you the link local up here, so whatever. And here they show you that we now have a fully specified IPv6 static route to a single host address. And host route is an IPv6 address with 32-bit mask or an IPv6 address with a 128-bit mask. They're automatically installed when IPv6 addresses are configured. configuration. They can be configured as a static host route. It allows for more efficiency for packets directly to the router, and the local route is marked with an L. Now, at this point in time, they're teaching you something that you should know already, but it is definitely something that that is relatively new. So I guess they felt like they had to re-explain it. This is an iOS 15 edition. It's been around as long as I've been learning Cisco. I've been always on iOS 15. I never used iOS 12, and that's probably a good thing. But iOS 12 and earlier did not have the link. And remember, the link indicates an exact address that is specified for a network, and it indicates, in this case, we're on, what are we on? We're on the branch router. It indicates this, this is the next hop IP, this is the exit interface. And even though it doesn't show you that, here, that this is the next hop IP, because it is a 32, we know it's a single address. Oh, I'm wrong. Yeah, the 1 is a single address. So if this is 1, a single address, this has to be 2. And it's not the next hop, it's the directly connected port and the directly connected network. Here's the directly connected network. That's the directly connected port. They take that to teach you now. If anything, we should have covered that earlier. And the same exact thing is true with IPv6. Note that you have the network, and then you have the actual port itself. And notice it's 128 instead of 32. And that is the end of this presentation. Not too painful. I used to go into dynamic routing as well, but it's really not necessary for you to be able to understand the content of this course, of this Cisco 2 course at this point to talk about dynamic routing. We come back to dynamic routing and we learn it later in the course. But we needed to know at least a refresher on static routing, because it does ask you, this module at one point, it asks you to create a static route. And since the problem was created because we went from CCNAv6, what I just taught you used to be taught in Cisco 2, but then they moved it to Cisco 1. Pretty simple concepts. And Cisco 2 people that didn't take Cisco 1 in CCNAv7, if they took it in version 6, well, then they completely skipped explaining dynamic routing. So it was important for me to cover it. And it doesn't hurt as a refresher in this class either. So if you have questions, my name is Don Lafond. You can ask. You can ask me questions right now in just a moment when I end the presentation, if you're here with me live. If you are in my traditional classroom, you can ask it in the help discussion forum if you watching this as a recording. And if you're watching this out in YouTube, please ask down below in the comments, and like my page, subscribe. Love it when you subscribe to my channel, and then you'll automatically get future videos when I release them. Anyways, it's been my pleasure helping you this evening. Thank you for coming to class. And I look forward to seeing you again in a week. Hopefully this presentation was helpful, and we'll learn more next week. So thank you so much for coming to class. I'll see you again in a little bit.